You know,
All right, so we'll start with some content overview with Ivan.
Okay, hey guys, good to see you all, and looking forward to seeing you on Monday. And I want to just briefly run through some of the math activities that we'll be doing and the focus and the progression. And in particular, I want you all to understand that all of the math, there's a progression that connects day one to day three. And the focus this year, of course, is on expressions and equations. But before we go there, I need to make a bridge first back to last year, which was on ratios and proportions. And from there, we're going to migrate over to generalizing beyond proportional relationships, which is, of course, y equals mx to y equals mx plus b. And from there are some activities that tie into expressions and equations, and even beyond that, what you do with, for example, multiplying binomials and combining like terms that generalize from just 2x plus 3x to working with monomials and polynomials, right? Because we have a high school contingent in the CAPP program where Iwana at CV, we only had middle school. So this group mathematically will be a little more advanced, so we push them a little higher than with the other program. So let's just get started right away. Also, one of the things you need to be aware of is that our time will be compressed because they have fewer hours in the day, and it ends at noon on Wednesday. So we actually have less time to do all this work. I don't know exactly how far we'll get, how much we can push, but I have more materials than we'll probably use, and just be aware of that. So let me get right into it. On Monday, after an extensive treatment on the MDTP by Anne Trescott, we're going to look at how mathematics is connected across various areas, like proportional reasoning, functions, and even transformational geometry. So we have a problem that Bruce had prepared, and I don't know if you guys received it already. I didn't send it out because that problem was not for me, but it's a problem that can be solved. I think it was a maximizing volume problem that can be solved using basically proportions and functions, and also even moving into calculus using derivatives. So the idea is to show how mathematics is connected. Even one problem can be connected across multiple content areas. So that will take us into our section on Monday on the mathematics, and we're going to focus first on ratios and proportions. In particular, I have a handout called Ratio Connections. It's a landscape document that you should have all gotten, and it works in conjunction with a GeoGebra app that I created. So the idea is that we want teachers to see how the ratio of a triangle, of a right triangle, such as say 10 over 40, right? A height of 10 and a base of 40, where the base is on the x-axis and the vertex is at 0, 0. So how that triangle, that right triangle with a ratio of 10 over 40, basically describes the slope of a line passing through the hypotenuse, right? Does that make sense? So if you have a triangle, a right triangle, I don't know if I could do this correctly here, but you see what I'm saying, right? A right triangle, the height is 10, the base is 40, the hypotenuse forms a line that has a slope of 10 over 40, which is 1/4. But if you extend that line out, and this is what the app does, and the base becomes 100, then the height of that triangle becomes 75. So 10 over 25, I mean. So 10 over 40 is the same as 25 over 100. Of course, that's the percent, right? 10 over 40 is 25 over 100. And if you come in and zoom in to where the base is 1, then the height is 0.25 or 1/4. And that, of course, is the unit rate. So slope, ratios, fractions, unit rate, percents are all connected in a visual dynamic applet where the kids can slide the sliders to make the base any size. They can slide the slider to make the height any size. And of course, when you zoom in and out, you can see all of these related figures. What's important about that in the worksheet, if you have it in front of you, is that it helps people think through all these connections, right? So suppose you got, you know, I think I said 4 points for every problem or something like that. I can't remember because I've been doing all these different activities. And then 4 points for every 3 problems correct. Those are similar problems, and the structure is the same. And then at the far right, when you solve the equation for y, you'll get y equals 1/4 x, or y equals or no, y equals 3x, 3 over 1x. You get 3 points for every, and then the other one is y equals 3/4 x, which of course is the slope because it's a proportion. And then moving forward, going down, the same structure to help the teacher see how that also translates to the same mathematical structure. The percent is equal to 3/4 times 100, analogous to 3/4 times x, right above it. So, so this is the bridging. And then moving forward, there are problems that work on, you know, making connections between slope and proportions, independent, dependent variables, and even using tables to help illustrate a lot of these ideas where the students can see how these numbers are related. The using tables activity in particular is then the bridge to the next phase, which is another key phase, or actually it comes on Wednesday, I think. I don't know when I'll get to it. It really depends on how fast we move. But if you look at using tables, you'll see these 4 tables. And I want to point this out in particular because it's super important that the teachers begin to realize that what we do when we're solving linear expressions and linear equations, the kinds that typical word problems where, you know, Noemi has 3 more cats than Nadira, that kind of relationship can be illustrated in a table because we want kids to see structure and use repeated reasoning. So the table, the first one says Tom has 4 more candies than Jerry. Right next to it is Maria is 3 times older than Juan. I purposely put these problems side by side because the 4 more, a lot of people will just, you know, get confused with 4 times. And I want to contrast what more represents versus times. And then if you look at the table values, the numbers ask kids to really think through the relationship. So with Tom and Jerry, 0 through 5 is provided, and then they have to do 4 more. So they just have to add 4, right? 4, 5, 6, 7, 8, 9. And then the second part of the table has numbers that kind of skip a little bit, but these 16 through 19 is provided as y values. So then they have to think, well, if Tom has more, then Jerry must have less. How much less? 4. So they have to go backwards and subtract 4. I hope that makes sense. And then some numbers that kind of go back and forth, and then the box. And the box is meant to illustrate any number, like a variable. If I started with the letter, the kids get freaked out right away. So putting a box there allows them to feel safe. Well, what goes there? It could be any number, right? So kids sometimes will put a number there for comfort. Can I put a number there? Sure. So, you know, Iwana might put 7, and Noemi might put 12, and Nadira might put 2. It doesn't matter because the structure is the same. Tom always has 4 more. So whatever you put, you're going to add 4 to it. And if it's just a box, it'll be box plus 4. And then you generalize that to a letter, n plus 4. And then below it, going the other direction. If the box represents what Tom has, then what's Jerry? Well, Jerry has 4 less. So it's take away from Tom to get Jerry. I hope that makes sense. And then directly below it, I want you to see how the problem is similar but yet different. It says Michael has $5 less than Jenny. So notice how in this example, I put the y column values first. I don't just put the independent variables like we typically do, right? Here I start them off with 9, 17, 25, because I want the kids to realize that Michael is the person with less money. So what do they have to do? So they have to go backwards. So not only do I put it in such a way where they can visually see I'm kind of going backwards, subtracting backwards, you know, that sort of double meaning. And then so Michael is 9 take away 5, as opposed to putting Jenny in the independent column and then Michael as 9 take away 5. You know what I'm saying? It's like I purposely put it there to sort of reinforce that point. So these are problems that eventually will bridge to expressions and word problems that that are more typical. And this representation is kind of a different way of looking at it. So it bridges the notion of dependent, independent variables with expressions and equations. In fact, when I teach these topics, I teach ratios and proportions first, and then I teach linear relationships before I even do the word problems. But once I launch into the word problems, I have all kinds of tools at my disposal to help the kids. So I'm going to stop right here for a second. In this first batch of activities, from ratio connections all the way to graphing expressions, what are some of your comments or observations and thoughts? Okay, well, I can move on
Don't
now.
all talk at once now.
I just want to give you a chance to process. I don't want to rush through and assume things. So if you move into Tuesday's folder of activities, um, I have a number of tasks that I don't know if I will actually get through. I'll try, but I don't know. But I want to highlight each chunk so you can understand where we're going with it. In the first chunk, it's going to deal with the y-intercept. The focus is going to be on the y-intercept. So for example, the um, the pizza problem or the Super Bowl Warriors party problem and the intercept problems all draw attention to the y-intercept. And in terms of helping your teachers think this through, help them notice what is going on in the stories and how certain things are different and certain things are not different. So for example, in the Super Bowl Warriors problem, you've got some people at a house and then people are coming over for the party, right? And it doesn't matter. The two activities are the same, just the setting is different. The big discussion that comes up in that one is how many people are in the house to begin with. The words say you and 3 of your family members. Some kids will put 3 because they see the 3, and some people will see that, hey, it's really 4. Now that's really important. That's by design, that we want kids to have that slight confusion, because what is not changing really is that the number of people coming with each doorbell is always 5. That's constant. That's a constant rate of change. So then they have to discuss, well, is it 3 or is it 4? What does that do to the problem? And that 3 and 4 is really critical because that's the y-intercept. You all know that, right? Because it's how many people are initially in the house to begin with. And that number affects the total. It's so important for the kids to see how 3 or 4 makes a difference, because that changes how many people are actually the total number of people. And then if you look at the intercept problem, the one that has the field trip, right? The 4 buses, and how the first bus has nobody on board, but the kids come on 5 kids per minute. And then the second bus has the driver and 3 tutors. The third bus, the fourth bus, right? That is intentional to help the kids recognize that the number of people on the bus, just like the party, affects the total number in the bus at any given time. And when you plot the points and graph them, you'll see that there are 4 parallel lines, and they all intersect the y-axis at different points, right? And that intersection matches the number in the column, in the row that has 0, 0, 0, 0, 4, 0, 5, 0, 10. And that is what we call the y-intercept. And then to formalize all of that, the activity called starting points, if you can skip to that activity called starting points. No, I'm sorry, finding rules, that one. Finding rules. You'll notice this is where we actually nail down this concept of y-intercept. Up to this point, it's been very informal, just kind of thinking through this number that seems to pop up, that seems to have an effect on the problem, not the 5. The 5 is the same among all 4 buses, but this other number, how many people are on the bus to begin with? So this problem called finding rules is more abstract, meaning there's no story there, because I now want the kids to formally understand what's happening. So there's a table, and there's some numbers in the table, and they can see that from one row to the next, there's a constant rate of change, right? And it's 3 over 1. And then they're asked to generate some kind of conjecture about a rule, and in particular, can they predict what it would be when x is 100? The graph provided allows them to graph only so far, right? If you think of each grid line as 1, they pretty much run out of space, right? When you get to 517, you're essentially out of space on the graph. So how in the world can you calculate the y value for 100? And that's where the math has to come into play. We're pushing kids to understand what the y value would be if they had to calculate it. And once they understand it's 5x plus whatever number is in the 0 row, not 5 plus -1, but 5 plus 2, right? 5x plus 2, they can now solve any problem. And then they feel pretty good about themselves. They get pretty excited, like, I just tell them, oh, okay, this is too easy. I'm going to give you a really hard one. What if it's 1,000? Can you do it now? And they all go, oh yeah, that's 5,002, and they feel super smart. But it's the same problem, right? 5,000 is no harder than 500. So the idea here is, or 302. So the idea here is that we formally define the y-intercept at this point, circle where it is on the graph, circle where it is in the table, circle where it is in the rule, and they can see that it's the same number. It's that +2 that always shows up. Does that make sense? I hope it does. So, and that's what that activity is all about. And then Enchante will do some stuff on functions using Desmos to kind of even generalize this further beyond just paper-based activities. So how does this, because we have high school people in the audience, how does this now translate to functions and maybe functions in general, not just linear functions, but functions in general? After lunch, we're going to come back and work on, I don't know the kind of time I'll have. I might start with the hexagon train task because it allows the teachers to see lots of different ways, because people will approach it different ways, as Iwana saw in Fresno, how different teachers attack the problem differently. And that lends itself into a discussion about mathematical representations and even how different representations can convey the same idea, and how we can illustrate different representations mathematically, even though when you simplify it, it all comes down to the same basic expression, right? So this now introduces us to expressions. And floor tiling is essentially, if you take a look at floor tiling, it's essentially a set of problems that deal with the distributive property. Because I'm asking kids to multiply numbers 2 different ways. They can multiply the sections, or they can multiply that to the whole. And then down below, when you get to problem 7 and 8, you'll see how it's changed a little bit, where I give them the 33 or 32. Let me see what it is. I have to pull it up. In floor tiling, down below it's 33, right? Problem 7, it's 12 times 33. Well, that's one way to figure it out, but then they can also split it up. So the kids will ask me, well, how do you want us to split it up? And I'll ask them, how do you want to split it up? And some kids might say 30 and 3. Other kids might say 20 and 13, or whatever. I don't care, because they understand now that it's really multiplying the portions and that adds up to multiplying the entire 33, right? I hope that makes sense. And then problems 9 through 12, you'll see some black splotches there, and I'll make up some story about how, when the person before you at the copy machine maybe used whiteout, but they didn't let it dry, so the whiteout stuck to the glass, and so when you put yours in, it turned into a splotch there. So the kids go, I can't see what number it is. What do I do? Well, then I asked them, what do you want to do? And they said, can we put any number there? I said, sure, but how do you know that's the right number? Well, we don't know. Well, then what else can you put? How about a letter? They will come up with that, and then we're home free because they've now generalized this to 13 times x plus 3 or 8 times w plus 3 or whatever it is, or in the case of number 12, 7 times x plus y, that kind of thing. And that's really what these activities are designed to do, is to move kids gradually towards abstraction. It's called progressive formalization, from concrete numbers that they can play with, that they feel good with, and then ultimately to generalized forms of that. If you look at the adding polynomials activity that I have here, that one kind of does the same thing, except now I'm asking the kids to see it in a vertical way, so that not only are we talking about simplifying expressions, but we're also looking at it vertically, almost as if they were, the decimal places when kids are thinking about place value. And so they understand that, hey, you can add vertically and still maintain the variables. It's really the coefficient that you're adding. So we're moving kids towards a generalized understanding of polynomials and monomials. And ultimately, if you look at write your own polynomials, I'm giving kids the solution, like number 1 is 4x squared plus 3x. So come up with your own way to make that possible. So they have to really understand the structure of the mathematics and not just mindlessly add or subtract or multiply and divide. I hope that makes sense, this sort of quick look through the progression from when I started to where I end up in this section. Good?
Yep.
Okay. Well, good for Iwana. The next section is called Picture This and More Picture This. So this goes back to understanding this sort of relationship between numbers, right? When something is bigger than something else, then the other thing is smaller, right? So it's really important that we help kids recognize how numbers are related to each other. So with Picture This, for example, you'll see that it starts out with this idea that, I gotta find it real quick when I'm doing this. No, got the wrong one up. Where did it go?
Ivan.
Yes, good time
Ivan?
to questions.
Do we have access to these right now? Are these in our something we have already?
They were all sent to you. So I don't know, Nadira, if you saw it in one of your emails, but they were all sent to you. Sharon.
Okay, that's what I'm looking for right now.
Yeah, that's why I'm referring to these things as if you could see them.
I haven't seen them. What is the files? Okay, hold on.
Okay, so let me just describe this one really quickly. With algebraic expressions, kids get really tripped up as soon as you throw variables in it, like x. So in the Picture This series of activities, I have a story about Sarah and her friend Jackie, and Jackie spent 4 times as much as Sarah. So I start them off by drawing a little square with shading that square represents what Sarah spent. And then Jackie, I have kind of an outline of a rectangle that's literally 4 times the size of Sarah. So the kids then themselves can draw in the lines to see that there are 4 squares there and shade those in. And so they see now, okay, I've got 1 box that represents Sarah and 4 boxes that represents Jackie. And the problem is together they have 60. So that means it's 5 boxes equals 60. And because they see 5 boxes, they realize that I have to split the 60 evenly into those 5, as opposed to 60 divided by 4. Right? A lot of times with variables, the kids might see, they might get this part correct. They might say, oh, Jackie is 4x, so 4x equals 60. They forget that it's 4x plus x. Next to it is a very similar problem using similar numbers, right? The 4 and the 60. But next to it, problem 2, it says that Jackie spent $4 more than Sarah, not 4 times. So they now know that here they don't do 4 boxes. It's 1 box plus 4. And then, of course, when they put that together, it's 2 boxes, 4 equals 60. And then they can, use their intuition to figure out what those numbers are, whether it's dividing by 2 or thinking, about how they don't have to even solve it using traditional equation processes. The idea is that we're trying to get kids to understand relationships. If one person has this amount and another person has 4 more, then it's plus 4. If a person has this amount, another person has 4 times, then it's 4, literally like 4 boxes. Okay, so that's what picture this is kind of about, and it kind of becomes increasingly abstract, and the scaffolds are being taken away between the first page and the last page, so that finally you don't even see any of that information, and they're just asked to figure it out on their own using their own diagrams. And that's how that set of activities, that particular set of activities, and that particular one kind of evolves into what's called more expressions, where now they see 4 expressions in a group, and they have the same numbers, but they have different relationships. So the first one says William has 3 times as many Pokemon cards as Raul. The second one says William has 3 more Pokemon cards as Raul. The third one says William has 1/3 as many, and the last one has 3 less. So the kids get to see how each of those translates differently. And that's that second chunk of problems. The last chunk of problems that we're going to give them has to do with solving the problems. So then there are more of these types of problems, but it starts out with some drawings to help them visualize how the problems are related, and then it eventually takes them into solving equations. So I'm going to have you look at equivalent equations 1. And this is where I'm going to wrap up here. Well, actually, the set of equivalent equations. Equivalent equations 1 starts with the very traditional image that I'm sure many kids have already seen. It's the scale balance with the box equal to some weight. So next to it, I have the symbols, x equals 12. Then the row below, I have the scale.
Sorry about that.
I can't quite argue with dogs.
I'm actually on a hangover.
Luana, you can
Sorry
always,
about that. Welcome to Jungle.
you can always mute yourself, and they can bark all they want. Okay? So if you mute, and then everything's fine. So the second row, I have printed. Hold on one second. I have printed the symbolic representation of the picture. My purpose in doing that is to force kids to look at what changed between one row to the next. So I've got x plus 6 equals 12, x equals 6. What happened? Something happened here. Similarly, I have 3x equals 12, x equals 4. How did that happen, right? So I'm forcing kids to think through the processes. If you want kids to write those yourself, there's a blank version of this one on the back side that the kids can do, or the second page. But really, the main purpose of this section is to move into the more slightly abstract representation of the scale. Scroll down to any of the other pages, and you'll see, for example, a problem that says 43 equals a stack of 4 boxes. 43 equals 4x plus 7. So by this time, they understand that if I just want to know what the 4 boxes balance with, I got to take away 7 from both sides. Take away the 7, right? That gives me 4 boxes equals 36. And then they can immediately see that I have to split the 36 equally among the 4 boxes. If you just wrote 4x equals 36, they often don't see that. But because they visually see the 4 boxes, they realize I got to split it 4 ways. And this really had a lot of success with kids who were struggling. And if you look at equivalent equations 2, you'll see the kinds of equations we have become increasingly complex. In fact, if you scroll down to equivalent equations 2e or 2f, you'll see that the equations are much more difficult than the other ones because I've got variables on both sides now. And the kids can easily see how if I have one box here and one box here, they balance. I can take them away. I can take away all the ones that are the same. So essentially, it's subtracting, for example, there's one on the bottom of 4e. I've got 6x on one side, 4x on this side, plus 12. So they can see that if I take away 4x from both sides, it leaves me with 2x equals 12, so each x has to be 6. And eventually, I even move into problems where there are negative x's. Now, obviously, in real life, there's no such thing as a negative box, right? But by this time, it's sort of quasi-abstract. The kids get it. I want you to look at one more, which is equivalent expressions 3. And you'll see these red dotted lines that kind of wrap around, and those are groups. And by grouping them, I'm now getting kids to think about it as distributive property. So we're making full circle. From the floor tiling all the way to here, the kids now understand distributive property not as a property to be learned unto itself, but as a means of making sense of problems. It's not just learning isolated properties, but here it totally makes sense, right? You've got 2 groups of x plus 1. And you can see clearly that it's 2 x's and 2. It's not 2x plus 1. So when the kids write it on the right side, when they have to write the symbolic, they're going to write 2 parentheses x plus 1 equals 16. And then when they expand it out, they have a visual that they can look at to see that it's 2x plus 2 equals 16. Or some kids might say if 2 groups equals 16, then 1 group will equal 8. So it's the same idea. They can solve it 2 different ways. So the idea here is that they begin to understand distributive property in context, not as a separate property unto itself. And that really is what this particular what this is all about. Okay? Questions? Yeah, they're
Is there a way
rushing me.
the maximizing volume one from Bruce? Because I'm looking through the emails and I can't find it, so I might.
I don't have it handy, so I'm gonna have to look for it myself.
Okay.
Okay? Why don't you send out an email real quick, Iwana? Hey, where's the volume one from Bruce? And then I'll look for it and then just respond to that email. Okay? Was that, I'm done. So I hope that was useful and gives you a heads up of what to expect next Monday, Tuesday, Wednesday.
So any other questions for Ivan in the world of content? When it comes to coaching, your coaching role, I'm going to go over a little bit of the logistical stuff. But Ivan, do you have any words when it comes to kind of the coaching role?
Yes, just very quickly, when you're working with your teachers, ask questions and help them think through these things. If you notice them going kind of, they're wandering, ask some questions to help focus their attention on the key things that need to be focused on. But also hear them out, because sometimes they come up with very good ideas and very good thoughts. In Madeira, we've noticed that some of the teachers who lack content knowledge actually came up with some very good questions that are beneficial. So listen to where they're at, be attentive to what they're doing, and it's not about computation. The one thing is we're trying to build relational understanding, how things are connected and related from one topic to another, as well as within the topic itself. That's really the main focus. We want them to develop this understanding of how math is connected and not isolated in separate topics. One of my mantras is teach tools, not topics. So distributive property becomes a tool, not a topic to be learned unto itself. It's a tool to help simplify and analyze problem types and situations. So be attentive, basically, to your teachers.
Thank you.
Thank you.
All right, I have to go. My ride is waiting. They've been waiting patiently for the last 20 minutes, so they're going to leave without me, and that would not be good. So anyway, I'll see you guys next Monday. I won't be there on Sunday, so I'll see you on Monday. Okay?
See you Monday.
Great.
Bye. See
Take
you
care.
soon. Bye.
All right, bye guys.
Thanks, Ivan.
All right, thank you.
Okay, so let me just quickly go through some of the logistical changes when it comes to coaching. I'm going to share the actual website. I've made some changes to the site. Can you see the website at this point?
Yeah.
Okay, so if you look, I'm at the teachers page, and so the home page for the teachers page right now are these 4 hot links. And if you find your teachers actually going to another page that is a lot more often as well, let me know and I can add it as a hot link. But what we've got, I'll just quickly go through these. The find your collaboration form, I'm going to hit that one during this call to talk about the collaboration form and that change. But here, basically, this is the page that takes them to the Google Hangout, how to do a Google Hangout, that info. This takes them to the page that has all of the math activities that Ivan and others have created and shared. So it's on this page is basically it's a window that has all of the activities in digital PDF form. So if they're looking for them, it's a hot link. And then this is the MDT page, and it gives you all the information about the guidance of MDDP. In fact, I'm going to go to that real quick because wait, make sure you still see it. Yeah, because of this. There's a top link to that page, which is called MDTP Guidance for Access, and that does give you a lot more information about specific stuff that teachers need to know when it comes to the MDTP with the Access projects, right? So which tests to use, when do I give it, how do I access it? So we kind of decided to give a lot more information than on the website than we have in the past. So that kind of helps, one-stop shop. So the teacher homepage, again, back to the collaboration form, that has changed. When the teacher needs to put in their hours, they go to the collaboration page, and there's a description of what they need to do. But then what they're going to do is come down here, and they're going to look for your name. So here's the CAPP coaches. So they will find your name, and so there is a specific form per coach teaching group. That makes sense? So if I click Nadira's here and go to Nadira's form, that's what they would do if one of Nadira's teachers. Then here's their names. They just have to select their name, and then what type of collaboration. And we're going to talk more about the types of collaboration. Sharon will be talking to the group with teachers and you all on Sunday as well. That we're not just requiring only Google Hangout. There is an opportunity for you to be in person with the coach, with the teachers as well. But this is the big new one, is that RTC collaboration. We talked about it a little bit at the coaching training in May, but it's that they can actually do some collaboration on their own without you. But what will happen is they do then need to collaborate with you based on what they did. So they okay, same thing. They'll tell us the date of when they met, the time spent, the focus of the session. But then this is that accountability piece to, if they did meet on their own without you, they have to put in here a date that they will or have sent you whatever they've done, what the activity that they built or something, some type of an RTC type of product that they did, and then you will be reviewing that and following up with them on whatever they did. And so this, the nice thing also, and you all should have gotten emails from me, you now have access to directly to the actual form. So let me quickly go to that real quick. Forms, hang on. You probably got an email from me via Google about the responses, right? So, see, I was on Nadira's. Let's pick that one again. So you should have access to this form here, which once they start to fill out the form, you'll get the real-time data as far as what they put in. So you'll have access, but you don't have editing access. You only have comment access. But if something comes up that you need me to edit or change, I'll be able to edit it. But you'll be able to still. The whole thing is to be able to see what they're putting in right away, and it's not this once a month I'm sending you an update. It's you have the update right away. So that's the change as far as when it comes to the form that the teachers fill out. So question on that right now?
Is there a place is there a place that said the MDTP, like they reviewed the MDTP as one of the choices, or?
Well, no. So yes and no. On the form, there's a question that asks them with a focus of the discussion and collaboration. So that's where they will just tell you. If it is that they were just reviewing the MDTP, I would encourage you to have them, if that's all they did, it would be nice for them to follow up with, okay, what are you going to do based on that? Not just, I reviewed it, now I want hours, but RTC is about responsive teaching cycle, right? So how are you responding to that? Is there a lesson? Is there something that you're doing to follow up with that? But this is where you would actually see if it was an MDTP. Does that make sense?
Yeah, I think Sharon, I read something on one of Sharon's emails that said they don't get hours for just reviewing the MDTP anymore. And it'll probably be something like what Chris said. It's in one of those many emails.
Yeah, the goal is not just hours to review, but the goal is the responsive part of the review, right? So that's what they would be claiming their hours for, is the responsive part of the review. The whole idea that RTC is what we're aiming for. Any other questions on that form or any of the logistics there? Okay, and then the other thing to show you would be your form. And again, your form, so when you go to the coaching corner and the coaching forms, you have your own individual coaching form as well. So it's not this, everybody doesn't fill out, I mean, I should say this, everybody fills out the exact same form, but it's not the same file. I hope that makes sense. So in other words, So again, I'll use Nadira. So if I go to Nadira's form, when she clicks her name, this is specifically, Nadira, your form you fill out, and then the data on the back end, you have access to what you input. So it's not going to be, again, where you're waiting a month or every other month for me to give you your update, but you get to see it, right, real time, what you put in. So it's a little different to where I'm not going to have everybody's stuff all in one place. I just now have to take everybody's stuff and I will put it into one place. Before I had it all in one place and I was separating it out for each of you. Now I'm going to now it's already separated and I'll just bring it all together for Sharon. So that's the difference in the change when it comes to how forms are done. Okay, so any questions on that?
Okay, so this is when we meet face to face with teachers. What about if we're reviewing their work?
So there's still miscellaneous hours. So we will have that form still exists, and you can claim miscellaneous hours for that.
Okay.
So that's where we would put in the hours that we meet with you on the coaches hangout.
Yep. Miscellaneous hours will be when we collaborate together on our Sunday evening hangouts, as well as if you're doing any prep or review work that doesn't involve teachers.
What about reviewing the work that they did?
Yeah.
Like they did an activity, they reviewed their NDTP, they created an activity, and they want us, like they collaborate with other teachers, and then they want us to review it and look at it.
Well, so part of it, though, is part of the review process is you're reviewing it with them, right? I mean, you may ahead of time take a look at it and do your own quick review, so you have an idea of what, but you want to have that conversation with them about. So it's actually, in a sense, they're going to get hours for creating, as well as there's going to be some Google Hangout time with you to discuss it.
But what Sharon was saying, that's what what I was getting from her was that sometimes we can comment back and forth on their activity that they did in Google, and not necessarily face to face at that time.
Oh, I see what you're saying. Kind of do it through email or through another chat to have some conversation that's not necessarily Google face to face.
Yeah. So I'm wondering if that just goes under miscellaneous, or is that separate?
Well, if that is considered, I think the question then, I guess this would also be a Sharon question. Maybe I should get some clarification from her on this, but because I would imagine the teachers are going to want to claim that time as well, because they're going to be conversing via email, and that's collaboration, right? I mean, it's not face-to-face collaboration. It's basically asynchronous, where you're doing it on your own time. So it should be that they're claiming that as hours. Therefore, you're going to claim it on your normal hours form as well.
Okay.
But how do you quantify
the
time on email back and forth? That's where it's just going to have to be a professional decision, I would imagine. But it would be good to get that clarified with Sharon, and I'll also follow up with her too. So that's good. That's a good question. So any other things? I know they're going to go through. Sharon will probably go through the web. I won't be there next week. At this point, my only project that I can do is San Diego, so I'll be at the San Diego one. So I won't see you all until face to face. I won't see you face to face. It'll just be our Google Hangouts that we do.
How about Robin? Is she going to be there?
Robin will be there. Yeah. Yep. Robin will be at all of them. Sharon's at all of them. Ivan's just about at all of them. But yeah, so if you've got any other coaching questions or what have you, let me know when it comes to some of the formalities. But other than that, you guys can have a good institute next week.
Thank you so much, Chris.
Yeah. All right, y'all.
Thank you, Chris.
You bet. Have a great.
Okay. Thank you.
You too. Bye-bye.
Bye.